Welcome to your lesson 7.5 video. I do think I'm going to be able to get this lesson all on one video. So let's get started. We're going to apply properties of logarithms. Alright, so you're going to rewrite logarithmic expressions. Now, just because of the way spring break falls and everything, I kind of want to go over a few things again. Remember the definition of a logarithm? We're going to let b and y be positive numbers with b not equal to 1. The logarithm of y with base b is denoted by log and then subscript to b and then y, and it is defined as follows. So we've got the log base b of y equals x if and only if b to the x equals y, and there's inverse relationships there. Recall that there are special logarithmic values that anytime you've got the log base b of 1, that's going to equal 0 because b to the 0 equals 1. When you have the log base b of b, that equals 1 because b to the first power is b. And the special bases of logarithms are 10 and e. A base 10 logarithm is a common log and is written just common log of x. And e is the natural log, or e is the base of the natural log rather, and is written ln x, but is read natural log of x. Okay, there are properties of logarithms. We're going to let b, m, and n be positive numbers such that b is not equal to 1 because we can't have a base of 1. The product property is going to be log base b of m times n is going to equal log base b of m plus log base b of n. Log base b of the quotient m divided by n is equal to log base b of m minus log base b of n. And the power property, log base b of m to the nth power is equal to n times log base b of m. And you need to memorize these. You need to know these and be able to use them. In fact, we're going to use them in both directions. We're going to take very condensed forms of logarithms, and we're going to expand them out. And we're going to take expanded forms of logarithms and write them in condensed form. Okay, here's condensed form. Here's expanded form. Okay, one way to practice is to start with some known values and use those to calculate unknown values. So we're going to use log base 4 of 3 is approximately 0.792, and log base 4 of 7 is approximately equal to 1.404 to evaluate some other logarithms. So the first one we have is log base 4 3/7, so that's 3 divided by 7, and so we can use the quotient property. Okay, so we're going to expand this logarithm, and then we're going to substitute. So an equivalent form is the log base 4 of 3 minus log base 4 of 7. And so now we can substitute in the approximations. And so we're going to have 0.792 minus 1.404. And we're going to simplify, and that gives us negative 0.612. Okay, we're going to do the log base 4 of 21. Well, 21 is 3 times 7, so that's the same thing as the log base 4 of the product 3 times 7. So once we have that, we can apply the product property, which tells us that it is equal to the log base 4 of 3 plus the log base 4 of 7. And now we can substitute, and we're going to get approximately 0.792 plus 1.404. When we simplify, we get 2.196. All right, now we're going to do the same thing with log base 4 of 49. Well, 49 is 7 squared, so this is equal to the log base 4 of 7 squared. So we can use our power property to bring that 2 forward, and so we have 2 times the log base 4 of 7. Now mind you, this power property only works if you're working with logarithms. People start wanting to apply it everywhere. If you aren't working with a logarithm, you can't do this. All right, we're going to use the given value of log base 4 of 7, And so this is going to equal, at least approximately, 2 times 1.404, which is 2.808. Okay, so now we're just going to expand. We're not necessarily substituting any values. We just want to write this logarithm that we're given in expanded form. We want to expand it out as much as possible. And we've got the base 6 logarithm, or log base 6 of 5x cubed divided by y. Okay, first thing we're going to do is use the quotient property. And so we're going to have log base 6 of the product 5x cubed minus log base 6 of y. Well, with that 5 times x cubed there, we need to use the product property to expand that out. And so we're going to get the log base 6 of 5 plus the log base 6 of x cubed minus log base 6 of y. All right, now we look to see if there's any powers that we need to apply the power property to. And there is. We've got this x cubed right here. So we're going to take this 3, we're going to bring it out front. And so we get log base 6 of 5 plus 3 times log base 6 of x minus log base 6 of y. And that is as expanded as we can get. So which of the following is equivalent to common log of 9 plus 3 times common log of 2 minus common log of 3? All right, so examining our answers, they're all written as a single common logarithm. This is an example of writing logarithmic expression in condensed form. They've given us expanded form with lots of pluses and minuses. Our choices are just all single logarithms, so the goal here is to write that expanded form of a logarithm into a single logarithm, into condensed form. All right, so let's recopy what we're given. And the first thing you do when you're going from expanded form to condensed form is you apply the power property. When you're going in the opposite direction from condensed form to expanded form, that's the last thing you do. It makes sense. Going in the opposite direction, it'll be the first. So the first thing we're going to do is any coefficients there other than 1, we're going to pop up as an exponent. Okay, so we're going to take this 3 and pop it up as an exponent of that 2. So this is our expression equals the common log of 9 plus the common log of 2 cubed minus the common log of 3. Now we're going to apply the product property. So right here where there's a plus, we know that these two anti-logarithms, 9 and 2 cubed, can be written in a single common logarithm if we connect them with multiplication. Okay, so we're going to use the product property going in the opposite direction that we did in the last example. So we're going to have, instead of 2 common logarithms, we're going to have a single one, and it's going to be 9 times 2 cubed. Okay, so we've done the power property and we've done the product property. What we have left is the quotient property, which makes sense that we're going to use that next because we got a minus here. For the separate logarithms, for the single logarithm, we'll have division. So we're going to have common log 9 times 2 cubed divided by 3. Okay, 9 times 2 cubed is 72, divided by 3 is 24, and so we have the common log of 24. So that means answer choice D is correct. Okay, last kind of problem we're going to look at is the change of base formula. Now, I'm going to be honest with you. When you are working where you can use your CAS, which you need to be able to do the change of base formula anyway, on the CAS, you are able to change the base. You can just go in there and you can make the base whatever you want. But many of you are going to be in situations where you're not going to be able to use your CAS. You're going to have some college professor that insists you use like really old school calculators from time to time, even when calculators are allowed. So you need to be aware of this change of base formula. If A, B, and C are positive numbers with B not equal to 1 and C not equal to 1, then, okay, we're going to start off with a base of C. The log base C of A is equal to the base B logarithm, or log base B of A over log base B of C. So you can change to any base you want as long as you take separate logarithms of A on top and C on bottom. So in particular, the ones we really care about are that log base c of a is equal to common log of a over common log of c. Or if you prefer to use natural logarithms, you can use natural log of a over natural log of c. Okay, so big number goes on top, little number that's kind of down on bottom stays on bottom. And you just have to be consistent. You can use common logs on top and bottom, or you can use natural logs on top and bottom. All right, so we're going to evaluate the log base 3 of 8 using common logarithms and natural logarithms. So using common logarithms, the log base 3 of 8 is equal to common log of 8 divided by common log of 3. And so that's going to be approximately 0.9031 divided by 0.4771, which is approximately 1.893. If we use natural logarithms, that log base 3 of 8 is equal to the natural log of 8 divided by the natural log of 3, which is about 2.0794, divided by 1.0986, which is approximately 1.893. You can also take your calculator at this point, now that you've worked the problem, if you want to check, and you'll see you'll get pretty much the same thing if you just put in directly into your calculator log base 3 of 8. Okay, that's it for this lesson. Make sure you do the problems to try on your own and come to class ready to do some practice problems. We'll get those rounds done. I hope you have a good day. I will see you really soon.